Hi, my name is John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. On this particular video, we're going to talk about the quotient rule of differentiation. Let's start. This is how the quotient rule of differentiation is presented in most textbooks. It says that when a function is given of the form u over v, okay, so the numerator and the denominator are functions. It's important to first identify when to use the quotient rule, and then obviously what is the quotient rule and how to use it. That's more important, okay? So you've got a ratio of functions, okay? In the numerator you have a function, denominator you have a function, and then you have to identify which one is u and which one is v. And here's the formula: dy over dx is given by du over dx. That's the derivative of the numerator times v, the denominator remains as it is, minus u, that's the numerator remaining as it is, times dv over dx, that's the denominator, the derivative of the denominator, the whole thing divided by v squared, that's the square of the denominator. A compact form of this one is, this is another form, okay, f prime of x times g of x. If fx and gx are numerator and denominator functions u over v, then it's f prime x times gx minus fx times g prime of x, the whole thing divided by gx squared. There is also a compact form of remembering this quotient rule. So if y is given as u over v, then the derivative is given by u prime times v minus a v prime times u, the whole thing divided by v squared. Okay, these are all the different forms of the same quotient rule. But like I said, one is to remember the formula, and the second thing is to know how to use it. So let's take some examples to illustrate this quotient rule. We'll take this question first, okay? This is y is given as x over log of x to the base e. This is the natural logarithm in the denominator. So we identify this as u over v, where u is x and v is the natural logarithm of x. As such, u prime is going to be 1, the derivative of x is 1, and the derivative of log of x, the natural log of x, is just going to be equal to 1 over x. So now it's about just putting it together into the formula for the quotient rule. As such, we'd get y prime as u prime times v, so that is 1 times log of x to the base e, minus v prime times u, so that's 1 over x times x, the whole thing divided by v square, which is log of x to the base e. Remember, it's a square, okay? V square. So that would be the derivative. Let's see what it simplifies to. This is just log of x to the base e. This one, the factor of x cancels off to give you 1 there, and the denominator remains as log of x to the base e, the whole square. That is y prime, okay? So let's just move the equal to sign out here. This becomes the derivative of the given function, which was x over log of x to the base e. What did we do? We just identified u and v separately. U was x and v was log of x to the base e. Differentiated them separately. So it's important to know all the rules. Then it's just a matter of putting it together. This is u prime times v remains as it is, minus v prime times u, the whole thing divided by v squared. Don't forget this, okay? This is square of the function in the denominator, okay? And then when we simplify it, you should get the final form of the answer. That's just knowing how to use your algebraic skills. Sometimes certain other factors will cancel off, okay? So that's how you differentiate a function that's given as a quotient of two different functions. Let's take another example. This time we'll take sin x plus cos x over sin x minus cos x. So I'm just going to write that question down here. This is y is equal to sin x plus cos x over sin x minus cos x. All right, so our numerator u is going to be sin x plus cos x. As such, then the derivative of the numerator u prime is cos x minus sin x, okay? Don't forget that. So the derivative of cosine of x is a negative sin x, okay? Then we take the denominator, let's use the same color, v is sin x minus a cosine of x, and its derivative v prime is going to be cos of x minus a minus sin x, okay? And that can be further simplified as cosine of x plus a sin x. This is just the derivative of the numerator and the denominator separately. Now you need to find out dy by dx, or the derivative of this original function, quotient of functions, and We can do that by using the formula dy over dx, which is the same thing as y prime. Okay, I often write it as with the prime notation because it's more compact. Dy by dx is u prime times v. U prime is this. Okay, so we've got cos of x minus sine of x times v, which is sine of x minus cosine of x, minus v prime times u. V prime was cos x plus sine x. It's getting longer, and that's v prime, and u is sine x plus cos x. Same term, sine x plus cos x. All right, this is just the numerator. Do not forget the denominator. The denominator is v square. So it is sine x minus cos x the whole square. Okay, that's v. V was sine x minus cos x. So that comes in the denominator whole square. And then after you've written it this way by using the formula for the quotient rule, then it's a matter of simplifying it. Okay, so that's why you need to know your algebra also well, not just the rules of differentiation. These two terms, cos x minus sine x minus cos x, they can be simplified and written something like this. You can write it as negative 1 times sine x minus cos x. Okay, so this term, I'm going to write it as negative 1 times. That dot means times. And here I've got sine x minus cosine of x. And the reason I did it is because this bracket and this bracket, they're similar except for that order of those terms here. And so I can factor out the negative because then I know that this is going to be a whole square. Okay, so it's negative outside, sine x minus cos x, and it's similar to this bracket. That remains as it is. This negative sign remains as it is. And here you've got similar brackets here, cos x plus sine x plus cos x. So that I can just group them together as cos x plus sine x or sine x plus cos x, the same, the whole square. Okay, and in order to get the same idea here, that's why we factored this term out here. And the whole thing divided by sine x minus cosine of x, the whole square. Cool. Now we can write this as sine x minus cos x, all right, the whole square, but there's a negative sign here. Don't forget that, okay? That's a negative. This time I'm just writing it this way, minus cos x plus sine x, the whole square. The whole thing divided by sine x minus cos x, the whole square. So then we come to this very interesting form, and there might be some way to reduce this further using some trig identities. Let's see what we can do in the numerator. This becomes the numerator, there's a negative sign, and inside the first bracket, we can open the bracket and say that sine square x minus 2 sine x cos of x plus a cos square of x. That's just the first bracket, okay? That's using the formula a minus b the whole square minus, doing the same thing for the second bracket, we've got a plus b the whole square. That'll give us cos square x plus 2 sine x cos x or 2 cos x sine x, either way. And then you've got a sine square x. Okay, and the denominator, don't forget the denominator. Whenever it gets so long and lengthy, you know, sometimes some terms just get ignored. So that's just sine x minus cos of x, the whole square. Okay, we can leave that because this one, I think the numerator might simplify. So we've got a term sine square x plus cos square x, and we know that is 1. Likewise, we've got cos square x and sine square x. That term is also 1. So this simplifies, the denominator can be further simplified as, that's a negative sign. The first term, we've got a 1 inside the first bracket, minus 2 sine x times cos x. And the second one with a minus sign, again, we've got a 1 that is cos square x and sine square x. That'll give you 1. And you've got a plus 2 sine x times cos x. All right, so that's just the numerator. And the denominator, we've got sine x minus cos x. That's a square. So let's see what will happen when we open the brackets. When you open the brackets, we get on the numerator, we got a negative 1 plus 2 sine x times cos x. And this one will be a minus 1 minus 2 sine x cos x. You see that? Denominator is sine x minus cosine of x, the whole square. Now we can see that this term and this term cancels off. We've got negative 1 and negative 1 that combine to give you a negative 2 over sine x minus cosine of x, the whole square. This is interesting. I think what makes it interesting is the usage of all the trig identities. And so therefore, I would say it's not just the algebra. Remember, in these kind of questions, we need to know, first of all, the rules for differentiation and how to use them. This is the quotient rule. We've already gone through the quotient rule. But more importantly, in these kind of questions where you have trig functions involved, you need to remember your trig identities also. And so you know how to expand them using the algebra, using your trig identities, how to bring it to the most compact form. So this is the final version of your derivative of the function, which was originally given as sin x plus cos x over sin x minus cos x. If you found this video useful, please make sure that you like, share, and subscribe to this channel. I'm going to see you all in the next video.